Mrs. John, and this lesson is on the change in momentum, and this is the importance of follow through. So, another way to calculate impulse or change in momentum is to look at the area under a force time graphs, and I've just drawn three examples of different shapes to get the area. So, if it's the area of a triangle, then you need to use half base times height in order to get the impulse or the change in momentum. And remember, force is measured in newtons, time in seconds, so you could have Newton seconds or kilogram meters per second as your area, as your impulse or change in momentum. So both these units are correct. Now, these two, the shapes are the same, you get the same answer, but what you notice is over here, a small force acting over a longer period of time will bring about the same change in momentum as a larger force acting for a small amount of time. And the other thing is that the change in momentum is the same as the direction. The direction is the same as the force that provides it. But if the force is small, acting over a long time, then there is less damage that is caused. So less damage when there's a long time and a small force acting. And here are some questions on impulse and force if you would like to take a look at it and check your answers and work through. So here's some more here for you. So just a word of advice, so don't forget arrows because all these are vectors. So if you have your arrows to show the direction, you shouldn't go wrong. And remember, if there's any subtraction of vectors, you always add the opposite. So make sure you keep the final momentum the same, and it is the initial momentum that is added but in the opposite direction, and do vector addition for that.